Okay, the next section in calculus deals with implicit differentiation. And what that means is it's just a different way of writing an equation as x and y in it. What we have discussed up to this point is what we call explicit differentiation, where we started with y equals 1 over x, and we wrote it as y equals x to the negative 1 power. The x's and y's are separated in the equation. You put them together, exact same equation, put them together in this form right here. This is called an implicit differentiation when we find the derivative of it. So they're together, and the process is kind of the same, as you'll see. And then the derivative, no matter how you write it, is expressed as dy dx equals negative x to the negative power, because you take the negative 1 over here and you subtract 1, then it gives you negative 1 over x squared, or you can write it as y prime equals that. Same thing. So there's different ways of representing different process, or the same process. So let's go to page 146, and well, before we do that, let's take a look at an example of how we would use that. So suppose we have this implicit equation, x squared minus 2y cubed plus 4y equals 2. Now, it would be very difficult to write this explicitly, where y equals some combination of x's, because we have two different exponents of x's here, or y's rather. So we're just going to derive it part by part, just like we would under normal conditions with just all x's. So like for this one right here, of course, the derivative of that is going to be 2x. So we're going to find y prime. Not put that in, but that's what we're trying to find, y prime. Now this right here, 3 times negative 2 is negative 6. Subtract 1 to the y squared. But this is the derivative of y with respect to x. So we need to put that in there. This is the derivative of x with respect to x, which is just 1. So 2x times 1 is 2x. So we don't put that in there. But it is implied when we go through that. Over here, same thing. X over here is 1, 1 times 4 is 4. And then 1 minus 1 is 0, so the y term drops out. But this is still the derivative of y with respect to x. And the derivative of a constant, as we know, is 0. So this is how we would take care of the derivatives in terms of x. Now, what we're going to do to find the derivative of the derivative dy dx is we're going to move this 2x over here and keep these dy dx terms together. We're going to do a little algebraic manipulation of this. So we subtract 2x, and this is negative 6y squared dy dx plus 4 dy dx equals, and this becomes negative 2x over here. Now we can factor out a dy dx here. Probably should put 4, but it means the same thing. So I'm going to take out a negative 6y squared and a positive 4 here. And that's going to be times dy dx equals negative 2x. And to get this to represent the slope at any particular moment in time on the curve, we're going to divide by this quantity right here. So dy dx, which is also y prime, the derivative of y, is going to be negative 2x over the quantity, and I'll put this in parentheses because it's negative something here, negative 6y squared plus 4. Or what I could have done also, if you don't like using the derivative, is write this as negative 2x over 4 minus 6y squared. And that's fine too. There's a number of ways, as long as it's correctly done, and we've gotten rid of all the negative exponents and the fractions that are fractions, then we're good. So that's how we're going to be doing implicit differentiating for the next two sections, and maybe more. We'll see. So again, let's open up the page 146. And I'll do a few problems here to kind of see where this is going to be headed. I'll do 5 problems here. I'll start with number 1. X squared minus 2y cubed plus 4y equals 2. And again, just treat this like a regular derivative problem. Wait a minute, we did that already. That's not number 1. It's supposed to be x squared plus y squared equals 36. That's a little easier. So this is going to be, with respect to x, there's going to be no dy dx with this. So this is 2x, and this is going to be 2y dy dx. The derivative with respect to x, and the derivative of 36 is 0. So we're going to move the x over here by subtracting 2x, and so we get 2y dy dx equals negative 2x. You can see the 2's are going to cancel out here, but we won't do it just yet. We're going to divide both sides by 2y, and dy dx is going to equal to negative x over y. And there's our answer. So that is our slope, dy dx equals y prime. Number 3, it's the same kind of problem, except now we have a fractional exponent, so I thought I would do this well to kind of get you comfortable with this process. X to the 1/2 plus y to the 1/2 equals 9. That's literally how it's written in books. They use the square roots. You give the square roots, just change this form here. Same thing, derivative of both of these. 1/2 x and 1/2 minus 2/2 is negative 1/2. Same thing here, 1/2 y to the negative 1/2. And now we have dy dx equals the derivative of 9 is constant, so that's going to be 0. So you can see pretty much the same thing's going to happen here, except now we've got these negative exponents to deal with. So I'm going to move the 1/2 x to the negative 1/2 power by subtracting it, so that gives me 1/2 y to the negative 1/2 dy dx is equal to the negative 1/2 x to the negative 1/2 power. And again, as you see, the 1/2 is going to cancel out here. So I'm going to divide both sides by 1/2 y to the negative 1/2. And this will give me dy dx equals, the halves cancel out, the negative does not, so the negative stays there. And this will be in the numerator, x to the negative 1/2. And this will be the denominator, y to the negative 1/2. Now, negative 1/2 means that it is a radical in the other side of the fraction. So the numerator becomes the denominator as a positive exponent. Denominator becomes the numerator because of the negative exponent. This negative sign stays the same. It has nothing to do with exponents. Negative, and that will be y to the positive 1/2 power, and x to the positive 1/2 power. Now, one quick note I want to make before we go on to the next practice problem is that some of these you can actually graph on your graphing calculator, but there's 2 issues with that. One, you take a close look at your x, y coordinate system on your calculator, you'll see that the x's and y's are not evenly spaced apart. Now, I don't know how much you remember from being pre-calc, but if you notice this right here, will actually give you a circle. Now, how would you go about graphing that on your graphing calculator? Well, remember, in your graphing calculator, it's y1 equals blah, blah, blah. So what we need to do is rewrite this so that y is by itself. Well, if you subtract x squared and then take the square root of both sides, you'll get the square root of x squared minus 36. Now, if you graph that in your calculator, you only get half the circle. Well, and the reason for that is because when you take the square root of something, you're going to get both the positive and the negative for this. So you should have for your y2 then, negative square root of x squared minus 36. You graph that in your calculator and you get some kind of ellipse. And it shouldn't be, but it is because of the way that the points are scattered, and therefore it is not something that you're going to want to require as far as defining a shape. Now this is a conic section formula. Ax squared plus by squared plus cxy plus dx plus dy plus f equals 0. That is the form for a circle when c, d, e, f all add up, all become zeros. So you just did that. And then that equals r squared, which is your radius squared. So the radius for that should be 6. And you can see that, you can kind of see the circle of the radius is 6. We do the same thing with this thing here, except this doesn't give us a circle, it gives us a parabola. But there's really no need for it, although what we are going to be doing for too long is we're going to be determining slopes on these curves at a particular point. Doing exactly the same thing, just plugging in values for both x and y. Where before we just had x because we had y all by itself on one side, or y prime rather for your slope, and then, but the equation was all in terms of x. Now we have a mixture of x and y's, so now we have to have the full scope of the point in order to figure that out. All right, so let's move on to number 7.